Okay, so we're going to talk about today exploring data, section 1.1, day 2 on this section. And we're going to calculate and display the marginal distribution of a categorical variable from a two-way table, and calculate and display the conditional distribution of a categorical variable for a particular variable value of the other categorical variable in a two-way table, and describe the association between the two categorical variables by comparing appropriate conditional distributions. Okay, first of all, what is a two-way table? Well, it's, what you might think, it's a table. There's two variables. Okay, there's a column variable. Variable 1 might be a column variable. Variable 2 is the row variable. And they're both categorical variables. And we'll see an example of one in just a minute. A marginal distribution is always of one of the variables in a two-way table. It's the distribution of the values of that variable for all the individuals. Okay, so essentially what we do with a marginal distribution is we ignore one variable and only calculate with the totals of the other variables. So we might have down here a totals row that would give us the totals for variable 1. If we wanted a marginal distribution for variable 1, we would use the totals row. Over here we might have a totals column. If we wanted to do a marginal distribution for variable 2, we would use the totals column. Marginal distribution is always using the totals. Okay? So let's see this example. Cell phones. The Pew Research Center asked a sample of 2024 adult cell phone owners from the United States which type of cell phone they own, Android, iPhone, or other, including non-smartphones. Here are the results broken down by age category. So you can see there are two categorical variables. A lot of times age is a quantitative variable, but in this case it is categorical because we're putting them into labeled categories like 18 to 34, 35 to 54, 55 plus. That makes age in this case is a categorical variable. And then type of cell phone is the other variable here. And so it says use the cell phone data to calculate the marginal distribution in percent of type of cell phone. So in other words, we're going to ignore age. So we're going to ignore all this stuff here in the middle. All these three columns in the middle we're going to ignore. And we're just going to look at iPhone 467, Android 503, and other 1054. And calculate, that's the marginal distribution for type of cell phone. So we're only going to use this variable. And so if we want to calculate that, let's calculate it in percentages, which is always a lot more helpful. 467 divided by 2024 is 23.1% that own an iPhone. 24.9%, we do 503 divided by 2024, own an Android, and 52.1% of people own other. And it says to make a graph to display the marginal distribution and describe what you see. Well, we can make two types of graphs. We're going to make both, but you don't have to make both. We can use one or the other. And we can make a standard bar graph, or first we're going to look at a segmented bar graph as we see it right here. So, and you can see it's exactly what we have. Our segmented bar graph, other, was 52%, Android was 24.9%, and iPhone about 23%. Don't forget to label your bar graph, your segmented bar graph. We could also make a standard bar graph and get the same results. Of course, we have iPhone, Android, and other. That's also one. Now, if we want to describe what you see. We want to tell what's the same, what's different, what interesting things are happening in our data. And so if we're looking at that, it looks like about the same amount of people own iPhone and Android, but more than half of the people own neither one, which is rather interesting. So that's what we say. About the same amount of people own iPhone and Android, but more than half own neither. And that's a marginal distribution. Now let's look at what a conditional distribution is, and we'll go through the data here. Okay. Conditional distribution. It's of one variable in a two-way table. It describes the values of that variable who have a specific value of the other variable. There's a separate conditional distribution for each value of the other variable. So I'm going to go back to the other page, and we'll come back here in a minute. But when we look, I could do the conditional distribution of type of cell phone. I would do 18 to 34 by themselves and see how did they shake out? What percents did they have? Did they have the same distribution as overall, or were they different? They could then do age for 35 to 54. Once we do a conditional distribution for those two, then we could start comparing them. We can also do it for 55 plus. Now we've done that. Let's look at the 18 to 34. We'll zoom in a little bit. Okay, a little bit. See if we can get them all in there. Close, maybe a little bit farther. Can we get them all in? Well, I think we can. Okay, so here's my 18 to 34 year olds, and 169 of them out of 517 18 to 34 year olds own an iPhone, so 32.6%. And 214 out of 517 owned an Android, and only 134 out of 517 owned something other than those two. You can see what those are. That we see. Let's call when we change it to percents, we call that relative frequency. When we're just doing count of in each group is a count, and that's called frequency. So you can see right away that the 18 to 34 year olds don't fit the overall pattern at all. Let's look at the 35 to 54 year olds, the conditional distribution for type of cell phone for 35 to 54 year olds. So looks like 26.8, 171 out of 637, 26.8% own iPhone, 29.7% own Android, and 43.5% own something other. So if we're looking at those two, comparing them, 25% of the 18 to 34 year olds owned other, whereas about 43% owned other. But in both cases, more than half of the people, in the case of the 18 to 34 year olds, 73% of them owned an iPhone or an Android, and over 50%, about 56% of the 35 to 54 year olds. So let's look at the 55. Okay. Well, we've got iPhone, Android, and you can see there's a big difference here. Look at this. 127 out of 870, so 14.5% owned iPhone of the 55 plus, 11.4% owned Android, and fully almost 74% of the 55 plus owned something other than one of those two. Okay. Those would be conditional distributions of cell phone type, and we didn't do it. So here it says use the cell phone data to calculate the conditional distribution of cell phone type for 35 to 54 year olds. We actually did it for all three. We did it for 18 to 34, we did it for 35 to 54, and we did it for the 55 plus. Now what we're going to look at is there an association between age and type of cell phone use? In other words, if we know somebody's age, could we kind of predict what type of cell phone they would have? And that's what an association is. An association, we say there's an association between two variables if knowing the value of one variable helps us predict the value of the other. Okay, so based on the cell phone data, is there evidence of a difference in the distribution of cell phone ownership for the three age groups? Justify your answer. Zoom out a little bit there. Okay. Well, if we're going to justify our answer, we would do some of what we've already done. We would calculate the conditional distributions for all three, which we did. We calculated the distributions up here, and we got our information about that. We already know, the percentages for each category for the 18 to 34 year olds, the 35 to 54 year olds, and the 55 plus. And once we have that information, we're almost always going to put that into a graph and see what that looks like. Okay, so what I did is made segmented bar graphs for all three groups. And this just is a graphic representation of the information that we already saw here. The information that we already saw was that 41.3% of 18 to 34-year-olds own Android, 32% owned iPhone, and 26% or so own something other than those. So we've seen all these numbers before because this is exactly what we did when we calculated our conditional distributions. Now we can look at this and we can start to talk about an association between age and cell phone ownership. And there's certainly, when we look here, we look, the iPhone and Android are over 70%. The iPhone and Android are over 50%. And then the iPhone and Android are under 30%. So certainly once you get to be 55, it looks like there is a big difference. So we'd say we believe, this is how we might write it. We believe there is an association between age and cell phone ownership. Over half of both 18 to 34-year-olds and 35 to 54-year-olds own iPhones or Androids, but only about 25% of 55 plus own iPhones or Androids. Also, younger people tend to favor Android, while older people slightly favor iPhone. That is a very good description of the difference that we see in our graphs. And notice we used the percentages. We talked about the percentages. We said over half. We did not necessarily use exact percentages. We have more exact percentages on our graph, and that would be a good description. This process here of describing and talking about making judgments based on data, this is a big part of what we do and something we want to get good at.